Our last section for Chapter 7, Logarithms, is solving using inverses or log equations and exponential equations, because those are the inverses. First, the same base inverse. If you look down here to start off with, when you have the same base, if I were to rewrite this as an exponent, this would be 3 raised to the x is equal to 3. So that means x is equal to 1. So just like if you had 5 times x and you're dividing by 5 to cancel, you have to use the inverse to solve when I have logs and exponents. They will always cancel each other out. So whenever you have a base of 3 and you're taking that base of 3 of the same number, those will cancel. Or if you have a log base 3 here, I could do log base 3, and again, these two will cancel out. So when you're starting with a log, you want to do the opposite of a log, which would be an exponent. And I'm going to get into more of this in the other slides, but it would be like 4 raised to the same base of 4. If you're starting with an exponent, you want to do a log. So this would be like log base 8, because your bases will cancel each other out. So let's move on. So when I'm starting with my exponent, I have to do log to cancel it out. So if I rewrite this equation, I have to do the inverse of exponent, which would be a log. And this has a base of 15. So I'm going to do log base 15 on the left-hand side. Remember, whatever you do to one side, you have to do to the other. So these two cancel each other out. So I'm just left with 3x on the left-hand side. Now on the right-hand side, I would either do your change of base or actually solve this using your graphing calculator. And log base 15 of 285 would be equal to about 2.09. And now I can solve just like normal. So on both sides, I'm going to divide by 3. And you get that x is roughly equal to 0.7. So right now I want you to pause the video, attempt to do the second question by yourself. Again, you're starting with an exponent here, so opposite of exponent would be to do the log. You should have gotten that x was equal to 1.51. Again, key here is you want to make sure that your base of the log should match the base that you're trying to cancel out. So log base 5 on both sides, and then divide by 2. 2 more questions to attempt to see if you can do this by yourself. Make sure you are working on these problems right now. The first one, you should have got x is equal to 0.25 by taking the log base 16 first as your first step. The second one, you should have gotten x is equal to 0.44 by taking log base 27 on both sides of the equation. So now what if you start with a log? How do you get rid of a log? You do the inverse, which would be an exponent. Now this kind of looks a little tricky. But I basically would be doing 10 raised to this whole thing. Why 10? Because when the base is not written, it has a base 10. That means I do 10 raised to this whole thing. So these two will cancel each other out. So on the left-hand side, I will just have my 4x minus 3. And on the right-hand side, this is saying 10 squared now. And 10 squared would be 100. And then from here, you just solve like normal. So you add 3 to both sides, and you get 103, and then you would divide by 4. You get x is equal to 25.75 as your final answer. So right now I want you to pause the video and attempt this next problem by yourself. Again, I'm starting off with a log base 10, so I should do an exponent on both sides of my equation. You should have gotten x is equal to 1.45. And I take 10 raised to this whole equation, that makes these two cancel out, and 10 to the negative 1 power is 0.1, and then you solve like normal, being careful that this subtraction stays with the 2. So I'd make sure to have this problem written down in your notebook. This is a great problem to have for a quiz. So in this problem, the first thing I want to do is rewrite using log properties. So with this adding, that's rewriting it as multiplication. So it'd be x minus 3 times x is equal to 1. Now that I have it rewritten, now I'm doing the inverse of log, which is saying 10 raised to the left-hand side 10 raised to the right-hand side. Again, this has a base 10 with nothing shown. These two cancel each other out. So I have x minus 3 times x is going to be equal to 10. And then this is your basic algebra problem. So with the two x's, I want to get this set equal to 0, so I'm going to subtract 10. At the same time, I'm going to distribute this x in. So this is going to become x squared, that's these first two x's multiplied. This becomes a minus 3x, and then I have a minus 10 is equal to 0. Because now it's a quadratic, and from here I factor two numbers that multiply to get negative 10, but add together to get a negative 3, which would be a negative 5 and a positive 2 is equal to 0. So I set both of these equal to 0, and now we get that x is going to either be equal to 5 or x will be equal to negative 2, and those will be my two answers. I want you to attempt this problem by yourself. So the first thing you want to do is rewrite this part of the equation so that there's only one log. So once you rewrite it, you should have gotten 6 divided by 3x, because subtraction is like division. Now you should simplify, so I could simplify this to be 2 over x is equal to negative 2. Now solve. Again, the inverse of log is exponent, and this has a base 10. You should have gotten x is equal to 200. So once I first take 10 and raise the whole left side of the equation, I have 2 over x left, and I have 10 raised to the negative second power. That's going to go to give me 0.01. Now, because I do not like x on the bottom of the fraction, I multiplied x on both sides of my equation, so that then I had 2 is equal to 0.01 times x. Lots easier to divide by 0.01, and that's where the 200 comes from. Make sure you took excellent notes and have a wonderful evening.